Hi guys, as another installment of the microcontroller series, I thought we would start with the smallest microcontroller that I have, which is the AtTiny85. AtTinys come in different guises. They will have different amounts of memory, like for instance there's the 2, 4 or 8K version of this little 8-pin 8-bit device. The AtTiny85 has 8K. It has quite a few useful capabilities. It has analog to digital converters. It has everything you would actually expect from a microcontroller. It has some EEPROM on site, 512 bytes, 512 bytes of RAM, and it has actually I2C and all those kind of serial outputs as well. It can run at 3.3 volts to 5 volts basically, and it is low power, so you can actually use it in a battery powered situation. Now, as you can see, this 8-pin device, but many of the pins have multiple uses depending on how you program it, what you want it to use it for. But in this discussion we will be referring to the pins as PB5, PB3, PB4, PB2, 1 and 0, and quite often in documentation that you will see and in various tutorials they will say, oh, hook up pin 0, and then you look at the chip and you're saying, wait a minute, there is no pin 0. Well, what they really mean is PB0, which is actually pin 5. So keep that in mind. We will be referring to those pin numbers as well by their names, so PB5, 3, 4 and so on. But if you look at this diagram, you'll see what the actual real pin numbers of the chip refer to. Pin 4 of the chip is ground, pin 8 is VCC. Okay, so what we have here is one of the Atmel Tiny 85s. As you can see, it's just an 8-pin DIP package. They do come in surface mount packages, which you actually see on this little DigiSpark board here. And they're even smaller than that, so if you're doing a very small project, you can actually use one of those. Now when you go to online to AliExpress or Amazon or eBay or whatever, you will find various little boards. This is one of them, a HW260. I purchased one of those, and I'm using it to, you can actually, like do the little blink sketch on there, and this little LED over there will blink. It's connected to pin 1, PB1. So, and it's got some decoupling capacitors and a few things on there, so that's kind of handy. And you can power it through the USB port, but you can't program it directly through the USB port. You have to program it to these pins. Now these pins are 8 pins here. They are simply connected to the 8 pins of the chip. And underneath there's a little table there, tells you which pins are connected on here. 5 volts, ground, and they're calling these P0, P1, but it's the same as PB0, P1, PB1 that we looked at earlier. So that's one thing. There is also, as I said, this DigiSpark board. This one is different. They actually as far as I know, they have already put a little bootloader on this chip, the AtTiny85. So you can actually plug this one into into a USB port, and you can, with the right driver, you can actually program it directly through there. But we'll be dealing with this in the second part of the video, so I'm just going to put this one aside for now. The most common way to program these AtTinys is via using an Arduino microcontroller, which can be a Uno, or in this case we're going to use a Nano. We'll be getting into that. For that I have created this little board. It's a little PCB that has some LEDs on there. This is an error, that's programming, and this is active. Some decoupling capacitors, and a little header here which actually plugs into this little header there. Now if you want to do a similar thing, we'll go to the wiring in that in a minute, but I would suggest using a little perf board like this. You can just stick the Nano on there and a couple of LEDs. These are optional, you don't even have to put those on, and there's only 4 wires plus, you know, ground and VCC to the Nano that actually connects to the chip. And you could put the chip socket directly on here if you really wanted to, or you could use the same thing I did and use this little board. There's a D13, D12, D11 and D10 on the Nano. And do keep in mind that when we say like D7, 8, 9, 10, 11, 12, you see over here, that is the actual names of the pins that we'll be referring to. And in fact, in the code, in the sketches, you would refer to that as pins 7, 6, 5, 4, 3. And it's same with the AtTiny. If I say hook something up to pin 1, it means PB1. It does not mean pin 1 on the chip, as we discussed earlier. So what I've actually done is I have made up a little cable, which is like basically a little crossover cable. It will plug into my little board that I made, and it then plugs into this little HW board. Again, there'll be links and information in the description to know how this all works and where to get the parts from. Now, what is actually different from this little chip is that it comes with nothing in it other than it knows how to communicate on some of its serial pins. And somebody has written code to send to this chip what's called a bootloader. And a little bootloader is a little bit of code that then knows how to accept the code from a sketch in Arduino and load it into itself and then start executing it. So all the other microcontrollers like the Nano and so on, and even that little DigiSpark board, I believe, they already have some form of bootloader in it. But invariably, to use this thing, you will need to download some code. In the DigiSpark version, actually, you got to get a Windows driver, and in this case, when we're going to be using the Nano is going to have some code in it that is actually going to communicate with the chip and after the bootloader has been done. So we'll be looking into that. Now this little Nano is something I had laying in my box, so I decided to make a dedicated programmer. It's an older one. I don't usually use these anymore. I use ESP32 for most of my projects, and you can see it's an older one because it uses one of those USB 3 mini B or whatever they call that, I can't remember, and which plugs into here. So let's have a look at a few other details. Now For reference, the wiring on this board here is as follows. This here I got out of the actual Arduino ISP sketch. It says that pin 9, this is on the Arduino Nano, is going to be the heartbeat showing the program is running. This kind of shows that it's active. That's that green LED that we got. Pin 8, so that's D8, D9, D7 of course, is the error. If something goes wrong, then it can light that one up. And the D7 pin is actually shows that it is programming, which in my case is the yellow LED. These are optional. If you don't care about those things, you don't have to put those on. If you just want to do a very simplistic thing, you can actually make a little program or write on a breadboard if you want to. And there's a few people that have done that. There are some other YouTube videos and some tutorials on how to do that, so I don't think I need to cover that here. To wire up the Arduino Nano to the AtTiny, or to connect it to the HW260 board like we have, there's no difference, is that the AtTiny Pin 8, that's the actual pin numbers, is VCC, which goes to the Nano pin 5 volts. Pin 4 is ground, goes to the Nano pin of ground. Pin 7 of the AtTiny, which is called PB2 or P2 on the little board, goes to D13 on the Arduino Nano. Pin 6, which is PB1, goes to the pin D12 on the Nano. Pin 5, which is PB0, goes to D11 on the Nano, and pin 1, which is PB5, goes to D10 on the Nano. So as you can see, only really if you stick it in a little breadboard, or you're going to make your own little perf board or something, there's really, at the minimum, you just got 6 wires to connect, which is pretty minimal. And if you add the LEDs, then that's like 9 wires. And all you need is a couple of resistors and so on. But I do recommend to put a capacitor from 5 volts to ground. I've got 2 of them. I've got a 100 nanofarad and a 10 microfarad, just to make sure there's no noise on the voltage. Okay, so for reference, I thought I would show you the diagram of the little circuit board that I made, the PCB that I made up that we're actually using here. The only thing is that I did not actually include the AtTiny socket, which is what this one is over here, but you can put that on instead of the little header. But in any case, this is the Nano, and as you can see, we have pin 10, 11 and 12, which corresponds to D7, D8 and D9, connected to 1K resistors and these different LEDs. We've got green, red and yellow I decided to use, but you can use any color you like. And of course it's got ground and plus 5 volts, and then the 10, 11, 12, which corresponds to pins 13, 14, 15 and 16 on the Arduino Nano, are connected to P2 or PB2, P1, P0 and P5, and I've got those connected to that little header over here to match the input of that HW260 board. But as I said, you could easily put the socket for the AtTiny right on your board if you're making one of those. So this is just for reference. You can pause the video here if you like and make some notes, or do a screen dump, and for reference. And this is what we have. So right, well, the first thing that you will need, if you haven't already got it, is to get the Arduino IDE installed on your computer. and you just go to again, there will be links in the description. Arduino CC and EN software. If you are a different language, you would have a different language there, I guess. You can just Google Arduino IDE, download, and it'll come up. And you'll want the Windows version. If you are on Linux, it'll work as well, but then the rest of this video might not make much sense, because I'm running it in Windows, and I think in Linux you would need to do probably add some different drivers and things that I don't even know about. For reference, these little boards, that HTW260 that I've got, is actually in various places on AliExpress. There's one here, and that is what we're actually using. But as I said, you can just use an ordinary little socket if you want to, but then you might have to put your own little resistors and things and capacitors on there or something if you want to protect it from voltage spikes and things. There are also other ones. These are kind of equivalent, but they have a different little header on there. And of course they also have the DigiSpark one, which as I said, we'll be discussing in the second part of this video. Now, if you do have one of these things or one of the other ones, I believe, and I cannot be entirely sure, that you might need one of these things. I think that you can actually plug that little socket onto that header on that other little board, and that you can use this as a programmer, and then you wouldn't need the Arduino. I've ordered one of those things. Once I have it and I've got it going, if it's useful, I'll do a little video on that, so you can look out for that as well. There is also another thing. These AtTinys, which is the one we got as the 8-pin socket. There are bigger versions of it with more I/O pins and more memory and what have you, and so on, I guess. And I've also ordered one of these little boards. I believe that this big one here is probably the one that came on the original Arduino Uno, maybe. I'm not sure, but it does seem to have the external crystal for a 16 megahertz oscillator, which you can certainly use with the AtTiny as well. There's an internal oscillator that it has to be, that can go up to 8 megahertz, but if you want a higher speed, you would need to use an external crystal, and it looks like they got that on that board here, and they even have some sockets there for other ones. I'm not sure. It appears to be a little kit that comes with all the components that you can solder on there. Once I have that, I might put it through its paces as well, and if need be, do a video on it if it is useful. Okay, so if you have your Arduino IDE installed and you run it, you'll get something like this. So the first thing that you'll be wanting to do then is go to File, Preferences, and over here it says Additional Boards Manager URLs. Open that up, and you'll be wanting to add this to it. If you look at the description, you'll find you'll be able to copy that from there. Once you have added that to the list, and clicked OK. I'm going to click cancel because I already have it. Then you would be able to go to a board manager over here, and you'll be able to type in ATT is all that's required, and you'll find a new board here, AtTiny by David A. Mellis. This is the person, I guess, that actually created some of this code to make them work, and we're very thankful for that. I don't know him personally, but in any case, if you see that here, board including spec is AtTiny254585, then there'll be an add button there. I've already added it, so it says remove, so I don't have to do it anymore, but this is what you'll do. Once you've done that, we can actually close that off. You will be able to actually plug in your Arduino Nano, and if you haven't, this one's already selected, but if you haven't, you would have select another board, and as soon as you plug the Nano in, as I just did, is you'll see a new COM port has appeared. Now I've used it before on my machine. It seems to come up with COM port 9, and again you can put, if you have a different Arduino board, if you're using the Uno, then you would type Uno obviously. So you have selected Nano on port 9, and as I said, on your computer that's likely to be a different numbered port, but it'll be listed there and you would select it. You can say OK, and then at the bottom over here you'll see Arduino Nano on COM 9. Okay, you can always click on the tools menu here, and you will see, and we'll be doing so later on. That's important because you probably have to change some of these settings once we get to the actual AtTiny, but we've got Arduino Nano port COM 9. This is an older one, so I guess it's an 80 mega 328p old bootloader comes up on mine. It's possible that there are newer versions perhaps that might use some of these other bootloaders. I'm not sure, but this is what we have. So then the next thing we will want to do is to go and go to examples. Come on, stay there. And you'll find an Arduino ISP. You click on that. Now I find this really annoying with this Arduino IDE. I don't know why they've done it that way, but when you load up a new sketch, for some reason it doesn't load it into your current window, but it will open a new window. So I'm going to close the old one then and use this new window. Now once you're in there, there's a bunch of comments over here which you can certainly read, but you can see this is where I got that information from to hook up these LEDs, heartbeat, error and programming. So the only thing you'll want to change in here is this line over here. I'm using a little, and delete the comment line so uncommented so that it is actually active. So use old style wiring, because we have them on 10 for reset, 11, 12 and 13, as you saw, we discussed earlier. So that is what we will do, and now you should be able to, with Arduino Nano, double check. It says done compiling, so everything is sweet. And now we should be able to say upload it to the Arduino. And it says done uploading. So now we have the actual programmer code in the Arduino Nano. So now we'll be able to create a new sketch for the AtTiny. Now I have one already called RGB test. So I'm going to close this one again. I'm not going to save it. And what I've actually done is I've created a little sketch over here for testing the AtTiny. We're going to hook up a button to pin PB3. Remember I said that's not the actual pin number on the chip. And the red and green and blue, there's an RGB LED with 3 legs on it. Oh, it's got 4 legs actually. One is for ground power. PB2 is going to be used for the red, PB1 is going to be used for green, PB0 is going to be used for blue. I create a little integer there for registering the current color. 0 is of course black, it's all off. Then in the setup we're telling it that the actual pins for red, green, blue and the button, what they are. Output, 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 button is input. I got commented out here the pull up thing because the little button that I'm using is on a little board which I have in my sensor box. Came with a bunch of sensors that already has a pull up resistor on it already, so didn't need it internally. Then if you go to the bottom here, the loop it does a digital read on the button and it says okay, if it is low then toggle the LED and delay 250 milliseconds helps debounce the button a little bit. And then toggle LED looks at the color value. It increments it by 1 first. If it's larger than 7, then set it back to 0, so it toggles round. If it is 0, then all 3 LEDs in that RGB LED thing is off. If it is 1, then one of them is on, which is actually red, green, blue. The red's on, and so on. All the 7 different combinations. And that is that little method here that it uses to do that. Passes in red, green and blue. So if red is true, then set it to high. If it's false, set it to low. Same for green, same for blue. So that's the little sketch that we have. Most other people are just using the blink sketch from examples. If you want to do that, then feel free. You can just go to examples, to basics, and go to blink. And in fact, that is quite okay to do as well. But I wanted to do something a little bit more significant. So at this stage then, you're going to go to select another board and port. We will not be changing the ports because the just to double check. Well, let's bring up the camera over here. You see how we still are connected to the Arduino, but the little AtTiny is actually connected. It actually has the little blink sketch in it. It's actually blinking its little LED in actual fact. But we are now going to pass code through the Arduino and program the little AtTiny that is connected over there. Or if you've made up a little board yourself, you might have the socket right on the board. Okay, so we are looking for a different board, and we should have AtTiny85 4585 there because we have enabled it in the boards manager before, and we're staying on port 9 and we're saying OK, and now we should be able to hit the little test. Okay, done compiling, it's happy. Now one little trick over here, if you click this upload button you'll get an error message. This has been like this since the earlier Arduino version 1.8, 1.6. I don't know if this is an actual bug or something, but it does not upload if you hit the upload button. What you really have to do in actual fact is hit the sketch and you'll say upload using programmer, Control-Shift-U. However, we have actually forgotten to do a little step here as well. Before you even do that, you have to go to Tools and you got to say Burn Bootloader. And look at the values over here. Board AtTiny25 4585, the port number, which is likely to be different on yours. The clock, set it to 8 megahertz. Processor AtTiny85, make sure that that is set to that. Programmer is ArduinoISP. Okay. Then you will want to click on Burn Bootloader. And the little LEDs on my little board, you didn't see that, was flashing. The yellow and light was flashing when it was actually programming it. And now if you look at it, you'll see it stopped flashing because a little bit of code was uploaded to it that is actually waiting for the actual software to the sketch to come through the Arduino to program it. So that is what you have to do. So now we should be able to go to Sketch and I'm on the wrong screen there. You should be able to go to Sketch and upload using programmer. Okay, done uploading. So that is it. We have created a little sketch. We have now loaded it into the AtTiny, and at this stage we should be able to take it out of the little board and plug it into a little breadboard for testing. So let's go and do that. Okay, so I have removed the chip from the little board over here, and I've put it in the breadboard over here. I've got it connected to power and ground and to the switch, and these pins are directly connected to the chip there. It's plugged into the breadboard. So I'm turning on my power supply. I'm actually giving it 3.3 volts. Proves that it will work on 3.3 volts, but it could all works just as well on 5. Okay, so if I push the button, red, green, this is actually yellow even though it looks white on the camera, blue, magenta, cyan, which means that green and blue is on at the same time, and this is actually white, and then it goes off again. So our little sketch is working. As you can see, the little chip is responding to the code we put in there. So that's it for if you're using the AtTiny85 chip by itself. This is one way of doing it. As I said, I've got some other programmers and things on order, and I will see how they work and I'll do a little video on that as well as an option. So now let's go to second part of this video, which we're going to be looking at this DigiSpark version. Turn the power off there, put that aside. Okay, let's change the cameras. Now this one is a different situation because I guess you could desolder the chip if you're really desperate, but the thing is that after you program it, you will have to connect with it via these pins over here. Either plug those into a breadboard underneath, or I'll put these extra pins in there for power, so I can actually power it externally, other than the doing it through the USB port. And this particular one, as I said, it is a different situation. You would plug it into the USB port direct, and let's have a look at what you need to do here in order to get that one going, because it is quite different. Okay, in order to get that one going, you need to go to the GitHub for DigiStump. Again, there'll be links in the description, and download the actual driver for Windows. And usually it can be a little bit confusing on this, but there's usually there is some zip files there that you can DigiStump driver zip. I think that's the one that you would want. So once you have downloaded that and unzipped it, you would get something like this, and you will see that there is a DP-inst64, which is what you would likely use because you probably on 64-bit Windows. If you have a really old version of Windows 7 or before or something, which I wouldn't recommend, but there is also a 32-bit version there as well, which is dp-inst-exe. And once you install that, you will find an extra port. I think it's coming up in my let me see now, device manager. On my machine, it actually ended up adding a USB serial CH340 COM11. Seems to be putting it on there. So you can use the Windows Device Manager to find that if you want to, but you'll see it coming up. Anyway, so that is one thing that you need to do. After you've done that, you should be able to go to File again and Preferences, and again you have to go to the additional boards manager URLs, and you should find that you have to add this DigiStump thing, that one there, and you would click OK. I've already got it, so again I'm going to click cancel on these. Once you've done that, you should be able to go to the boards manager, and you should be able to type in DigiStump AVR boards and type add. So that is what you would do. I've already got it installed, so I don't have to do that. and at that stage you should be able to, it's actually already found it, but if you select other boards, you would say, oops, DigiSpark default, and it has already know that it is on COM11, so it's already got that checked. You click OK. But for this one, we're not going to be running this RGB test. I could if I plugged it into breadboard, but let's use the ordinary blink sketch then. Again, close this one, maximize that one, and we will be changing that to PB1, so that's pin 1. Let's make it faster so we can, 1/3 of a second, just for good measure. Now if everything is well, again you can go to the tools menu, and you should be seeing over here board DigiSpark default 16.5 megahertz, port COM11, and now you should have a programmer that says micronucleus. And you might remember from the earlier when we were looking at this driver, see micronucleus exe, that's part of the driver install. I didn't have to do anything to make that happen. It seems to put 2 and 2 together. So let's have a look. It likes the blink sketch, and now you don't plug the device in yet. This is the thing that is a little bit odd about this and different. So you leave the device unplugged, and then you would say upload, and it says plug in device now, and I'm plugging it into the USB port, and there it goes, and it is done. So there it is, it's still plugged in, and it's flashing its little built-in light. So that's it for the DigiSpark. And as I said, now if you wanted to use this in one of your projects, you can, you know, plug this into a little board like this, and you know, provide power to it, and it would work. Okay, so I plugged in some power over here. Those 2 power pins I've actually on purposely put on the bottom of it so it fits in a breadboard like that. And it is going. This is why I soldered on those 2 pins there underneath as well on those, so when you got a breadboard with the double power lines there, you can actually just plug it in and provide power to it that way. Okay, so I think that kind of completes this video on these 2 methods of programming and using the AtTiny, and there will be some others if I get those other things working. And on part 2 of the video we are going to look at how to interface with this chip on I2C or I2C, whatever you want to call it, and expand its ports and hook it up to a common LCD display, and discuss a few other methods of expanding its I/O. Also, I've got a little project coming. This is a little board over here that I've made up, and that is going to be housing this little empty, I think it's a 2805. It's a little buck controller, and the idea is that this one here you can use with like a lithium ion battery, and with just a few components, a little capacitor, a little inductor, and so on, you'll be able to run like an AtTiny off it. And yeah, I can imagine you can have a little board like that, and the AtTiny is sitting on there, probably the surface mount one, you know, the smaller one like that one on here, and one of those little guys, and a little lithium ion cell, and you can have a little battery operated project, some sort of Internet of Things type project or something. Anyway, that's coming. Please subscribe and like and all that kind of stuff. I'm still looking for a few more subscribers. That'll keep me going, and I'll see you guys later.